In this video, we are going to learn about Kepler's law of planetary motion. Kepler gave three laws. According to the first law, every planet of the solar system, every planet revolves around Sun in an elliptical orbit. With Sun situated at one of foci of the ellipse. So every planet revolves around the Sun in an elliptical orbit, with the Sun being at this focus or this. So this is Kepler's first law of planetary motion. Now second law of planetary motion, it states that the line joining the Sun with the planet sweeps out equal areas in equal intervals of time. That is, aerial velocity of the planet is constant. So according to the second law, the line joining planet with the Sun, that is this line, sweeps out equal areas in equal interval of time. So suppose this is Sun and this is planet, and this is the line joining the planet with the Sun, and after delta t time the planet is here, and then this will be the line joining the planet with the Sun, and delta t time change in position. In delta t time, planet moves from here, from A to B. So if planet moves from position A to position B, then the area covered by the line joining the planet to the Sun in delta t time is this area. This is the area which is covered by the line joining the planet with the Sun. Then according to the second law, that for every interval of delta t time, this area will be constant. That is, if we take a delta t interval of position of planet from here to here, then this area will be same as this area. Let's say O D C. If the interval, a planet moves from D to C in delta t time, and if planet moves from A to B in delta t time, then according to the second law, the area covered by the line joining planet to the Sun in delta t time will be same. So area OAB is equal to area OCD. Now proof of this law. Since consider the system of planet and Sun, then the system of planet and Sun then in this system no external torque or no external force is acting, no external torque acting. Due to this, the angular momentum is conserved. Due to this, the angular momentum of planet is conserved. Since the system of planet and Sun is isolated and no external force is acting, so no external torque is acting on system of planet and Sun. That's why the angular momentum of planet is conserved, and we know that an angular momentum is equal to 2m dA by dt. Now since L is constant, implies that dA by dt is constant. Implies that dA by dt is equal to constant. Our aerial velocity of the planet is constant, which is Kepler's second law. Now Kepler's third law of planetary motion. It states that the square of time period of revolution for a planet is directly proportional to the cube of semi-major axis of the elliptical orbit around which the planet revolves the sun. So T is time period of revolution. So T is equal to time period of revolution, and R is equal to semi-major axis of its elliptical orbit. Now let's prove this law. We know that the planet revolves around the sun, and for the planet to revolve around the sun, required centripetal force is provided by gravitational pull of sun. So gravitational pull is equal to centripetal force. Now gravitational pull is equal to G into mass of sun to mass of planet upon the distance between sun and planet, is equal to mass of planet into radius of orbit into the square of angular momentum. Since the centripetal force is given by mv square by r, we can write m r omega square by r is equal to m r omega square, where omega is angular velocity of revolution. Now omega is equal to 2 pi by t, since 2 pi is angle completed in one revolution and t is time required to complete one revolution. So 2 pi by t is equal to angular velocity of revolution. So from this we have g, mm will cancel out, and m, if we take by r square, is equal to r 2 pi upon t whole square. So this becomes gm by r square into r 4 pi square into t square. R, if we take t this side and r this side, we will have t square is equal to r cube 4 pi square upon gm. Implies that t square is directly proportional to r cube, since 4 pi square upon gm is constant. And this is Kepler's third law.